So I've given you a printout of this particular function. Please make sure that you have it right in front of you so that you can follow along. So you'll notice that the label in this graph is f prime of x. What I'm going to do is I'm going to put a cloud around that, and that's what I typically do to remind myself that this does say f prime. Okay, so let me write down the rules. I'm going to do that further down here. And what are the rules? Let's see. If f prime is positive, then f is increasing. If f prime is negative, then f is decreasing. If f prime equals 0, then f is constant. Okay, so we're going to keep that in mind as we go forward. All right, so as I mentioned, this is a graph of f prime right there. So I have to look at what is described on the left, right? My f prime positive, f prime negative, f prime equals 0 in order to sketch out a graph of f of x. So that is going to be a primary concern for us. Now, what I typically do is I try to make sure that I pay attention to what happens at the x-axis. Okay, so before I even get started, I put plus, plus, plus above the x-axis, and then I put minus, minus, minus below the x-axis so that you can see, you can direct your attention to simply above the x-axis, at the x-axis, below it. All right, so the transition happens right here when f prime hits the x-axis. Okay, so I'm going to use red to indicate this part right here, and I'll use purple to indicate this part here. All right, so let's write down what's happening here from negative infinity all the way up to x equals 3. We have f prime in the negative region below the x-axis. F prime is negative, which means f has to be decreasing. So if I need to sketch out f looks like this. There's f. Okay, so over here, notice if we write from here on, right, f prime is in the positive region. It's above the x-axis, so greater than 0. Notice these rules are right here. You should be able to look at them. Look, if f prime is positive, that means f is increasing. Okay, so that means f looks like that. So f is constant at x equals 0 because f prime equals 0, so you can just round that off. Right, so if I asked you a set of questions about f, you should be able to answer them incredibly quickly. So if, for example, I said, where is f increasing, you can look right at your function and say, oh yeah, negative infinity to 3. If I asked you, I'm sorry, correction, I'm not looking at the right one. Where is f increasing, you should say from 3 to infinity, right? That's a mistake on my part. If I ask you where is f decreasing, you're looking at f, you just sketched it out. F decreases from negative infinity to 3. And then where is f constant? There it is. Okay, so let's try another one. Okay, you do have examples of these in your homework, so please do those problems. All right, so let me show you what this reads. Another graph of f prime. So let me put a cloud around that. Kind of big about the clouds because I always have to remember what the rules are. So I'm going to quickly sketch out the, write down the rules. If f prime is positive, then f is increasing. If f prime is negative, then f is decreasing. If f prime equals 0, then f is constant. Let me remind you, we have the graph of f prime, so we need to look at these descriptions right here. Above the x-axis, below the x-axis, at the x-axis. So let me go over here and put plus, 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 0, minus, minus, minus. I do not care that this function is going down and then going up. I only care about above the x-axis for f prime, at the x-axis, and below it. Why? That's the description we just used right there. All right. So I'm going to pay attention to where my function hits the x-axis. Why? Because that's where f prime equals 0. That's where you're at the x-axis. And here as well. And then I am going to try to pay attention to this piece right here. So from here all the way up to x equals, looks like x equals -1. What can we say? Oh, f prime is above the x-axis. So f prime is in the positive region, which means f has to be increasing. Okay, I'll come back to that in a minute. So then here, from here to here, what can we say? We can say that f prime drops below the x-axis. You can see it the entire time your region is below the x-axis. What does that mean? F has to be decreasing. And then, last but not least, this region over here, what can we say? F prime is above the x-axis in the positive region, so f has to be increasing. So if I wanted to sketch out f of x, I certainly should be able to do that. Okay, so I'm going to put it down here so we have enough space. Look, f prime is positive means f has to be increasing in here. There's f of x right there. And here f prime's negative, which means f of x has to be decreasing this entire time. Make sure that you decrease for the entire length of the time. And then last but not least, this one, f prime is in the positive region above the x-axis, so f has to be increasing. So you should be able to answer questions with regards to what f of x looks like because you sketched it all out based off of the rules for f prime, right? So notice I'm going backwards. All right, so you could do one that's even more complicated than that if you so desire. Okay, it's the same principles though, right? So you guys have the rules down, written down somewhere, so I'm not gonna write them down this time. All right, so I want to pay attention again to where f prime, let me show you, this is f prime, it's the x-axis. I'm going to go over here and carefully label my graph as positive, above the x-axis, 0 at the x-axis, and negative below the x-axis. Again, I want to direct my attention to where my function is. F prime is above the x-axis, at the x-axis, and below the x-axis. All right, so let's see. Let's start here. F prime, wait, let me write my dividing lines that indicate the critical points. Right, I'll get to that in a minute, but I do need to make a point of that. There, and then here. Okay, please do these problems. It's a very common question to ask on an exam. All right, so let's look here. All the way to that point. Okay, what can we say? From here to here, we can say f prime is in the negative region. Why? Below the x-axis. All right, so notice as soon as you write these points down, you know that you have to go from point to point, right? And see what's consistent. So we go over here, like that. And so this entire time, what can we say? F prime is positive. Okay, so from these two critical points for f, or transition points, then what can we say? We can say that entire time f prime drops below the x-axis. F prime is negative. And then last but not least, over here, right there you can say that f prime is positive. All right, so let's think about what that means for f of x. So I'm going to do these ones in here since I still have the purple pen in my hand. Since f prime is positive, this means f has to be increasing. This one too means f is increasing. And if f prime is negative, this means f is decreasing. And this means f is decreasing. So let's see. Let me try to sketch that out. I'm gonna put it down here. So in this region, if I want to sketch f of x, right, the original function f of x, I could say all the way up to this, f should be decreasing. And then to this point right here, f should be increasing. And then here, f should be decreasing. And then finally here, should decrease all the way to that point, by the way. And then in here, f should be increasing, right? So you guys need to be paying attention to the specific points where that occurs, because I will ask those questions.